Hello, you're welcome to today's lesson, and today we are still treating latitudes and longitudes. We have a question on the board. My name is Harrison, and we're about to start. Question on the board, we are to solve. We have an aircraft moves from a location P, 28 degrees north, 15 degrees east, to another location T, 28 degrees north, 25 degrees west, and then to a location Q, 32 degrees south, 25 degrees west. We have to calculate first the radius of the parallel of latitude 28 degrees north, the distance P to T, and the distance T to Q, and then finally the average speed of the whole journey if the aircraft took 20 hours to cover the journey. Solution. We locate the point P first at the northern part. So this is the equator, and then we now locate 15 degrees east. So we are taking this to be our P, and then to another point T, the same 28 but 25 degrees west. So we have this and this. So this is our T. Okay. And then finally, from T, we have another point Q, 32 degrees south, and then 25 degrees west. That means through this longitude. So let's take this to represent that. So we are taking this to represent our Q. So we have this. Now the distance between P and T is along parallel of latitude, while the distance between T and Q is along the longitude. So the first thing we have to calculate small r. That means we can have something like this. So this should be our P, T. Let's call this theta 1. And then for us to calculate theta 1, you have to check to get the angular difference. You have east and west. So theta 1 is equal to east and west, we have to add. That is 25 degrees plus 15 degrees. And that is 40 degrees. Now we keep that, and then we go back to find the radius of parallel of latitude 28 degrees. So question 1, radius of parallel of latitude 28 degrees, latitude 28 degrees north is given by the formula r equal to kappa r cos alpha, where our alpha is 28 degrees. So in order to continue, we have therefore r is equal to 6,400 cos 28 degrees. And that is 6,400 times, you look for cos 28 degrees. So checking our calculator, we have 0.8829. And then when you multiply, you have 5650.56 kilometers. Okay. Now, that is the radius, and that's the small r. So then the next thing, second question now. The second question, we have to calculate the distance between P and T. Distance between P and T. That is from P to T. And then that is arc PT. So arc PT is given by the formula theta1 over 360 times 2 pi r, because we are talking of distance along parallel of latitude. So coming up, we continue from here. So we say that arc PT is equal to, from here now, that is 40 over 360 times 2 times 3.142 multiplied by, because 3.142 is our pi, and again we have calculated r here, so we just fix this here. 5650.56. Then you carry out the multiplication using our calculator. That will give us 1,420,324 324 that will give us 1,03616.7616. Then all over all over 360. Okay, so when we divide, we are going to get 3945.35 kilometers. Take note that we have already calculated r, which is this. So instead of continuing with r cos alpha, I replace this value here, and that is why we have it here. Okay, to make it shorter for us. So that will give us, okay, we have this as our answer. So that is the second value now. Then the next one, We now go to the third question, which says the distance T to Q. So we are now talking of arc TQ. And arc TQ should be theta 2 over 360 times 2 pi capital R. Capital R because the center is from the big center. So we are using capital R. The distance is along longitude, while the other one is distance along latitude. So in this case now, to get our theta 2 should be equal to, we go back, you know we have north and south. So since this is north, this is south, different positions, it means we have to add. And in order to do that, we now pick the values, which is 32 degrees plus 28 degrees. And that will give us 60 degrees. So to continue, we have 60 over 360 times 2 times 3.142 multiplied by 6400. Then you carry out the multiplication, and then we arrive at coming up here, we arrive at arc TQ should be equal to, you multiply all this, and that will give us 2413, 056. We are dividing by 360. That will give us 6702.93 kilometers. So we have succeeded in getting at TQ as well as PT. So to move on, we have calculated this, and before we calculated this, so we are now going to the final stage, which is number 4th question, average speed. So, but before we talk of average speed, we have to calculate the total distance, because average speed is total distance over total time. So, P T plus TQ should be equal to, we pick the values, we have PT at PT, we had it to be 39, that is this, 3945, 3945.35, okay, plus 6 plus this one, 6702.93 kilometers. And finally, that will give us 10648 kilometers. Okay, then the next thing is for us to calculate the average speed. So therefore average speed should be equal to total distance all over time, and that is equal to 10648.28 all over we'll go back 20. Finally, we divide it, you now have 5 approximately equal to 532.4 kilometers per hour. 532.4 kilometers per hour. So this is the average speed. So you have seen how we solve the question. First of all, locating the points, followed by calculating the radius first, the distance between PT, distance between T and Q, and then the average speed. So please like, share, subscribe, and if there's any comments or any question, you put it in the comment section so that in my next video I will find solution to it. Thank you.